Hello, my dear students. Welcome back to this lecture. So, in this lecture, we will see how the BBS for a gun bar is to be calculated, or for the Chajja bar. Okay. So, this is called as gun bar. So, your bar will be something like this. It will come like this. Okay. Give me a minute. Yeah. It will come like this. Then it will be going like this. Then it will get a turn like this way. It will go all the way like this. It will be like a stirrup. Okay. And then it will be bent at a 135 degree. Okay. You cannot see that, but practically this is how it has to be bent here. Same thing I have shown it here. It will come like this. It will go in this way. Okay. The same bar will bend like this. Then it will become a stirrup from here. It will take a shape of a stirrup. It will come like this. It will come like this and over that, and then it will be bent in this way. Understood, right? So this is how the bar looks, and we are supposed to calculate the bar bending schedule for that. So this is a beam what we have. The depth of the beam is 500. The width of the beam is 300. And the thickness of the Chajja, this is a cantilever, and thickness of the slab or thickness of a Chajja is 150 mm. I written it here. And this is your top steel. Okay. This one here is your top steel. And the black color one is your distribution steel. And these are the stirrup for the beam. So all the three, they have given it is a 10 diameter bar, and the spacing is 150 center to center spacing. And from this outer to the inside of this beam, I mean up to the outer of this beam, I can say this length is 800 mm what they have given. Got it? So we'll start to do the calculation for that. So this is a cutting length formula. It's very simple. I'll explain you how we have to understand. So we'll divide this thing. I'll name this as A. Let me do in this way. I'll name this as 1. This particular point as 2. This particular point as 3. This particular point as 4. This particular point as 5. This is 6. This particular point is 7. And then this particular point is again 8. So if you don't understand here, I'll do one thing. I'll start like this. Okay, this is point number 1. So it is easy for me to prepare the BBS. This is point number 2. Wherever there's a change, or wherever there is a bend, I'll take it as one point. So 1 and 2. This is my third point. This particular point is fourth one. This is fifth point. This is sixth. This is seventh. This is eighth one. Got it? This much you understood. So I've written the same thing. The formula I've written like 1 to 2. 1 to 2 means this length. 2 to 3 means this is 2 to 3. So 2 to 3 means from here to here, this length. Plus 3 to 4. This is 3 to 4. Plus 4 to 5. This is 4 to 5. This is 5 to 6. This is 5 to 6. This is 6 to 7. This is 6 to 7. This is 7 to 8. This is 7 to 8. Plus you have this hook, right? So this is that hook which has to be bent at 135 degrees. So this hook length I'll be adding. And wherever the bend deduction, if you want to do, you can do the bend deduction. This much is clear? Good. Now, first I'll go with 1 to 2. This is enough. Now take this as a reference. So 1 to 2, what I'll do? I know what is the thickness of this. So this is 150 mm. So I'll remove one top cover. I'll remove one bottom cover. I'll get the height of this. So I've done the same thing. This 1 to 2 is 150 is the thickness of your Chajja. I'll deduct one cover from the top, which is 20 mm. I'll deduct one cover from the bottom, which is 20 mm. Another thing you need to understand, the cover for the Chajja. So cover Chajja, I'm taking it as 20 mm. In few people they take it as 15 mm. So in my calculation, I'm taking 15 mm. You also can take 20 mm. Sorry, in my calculation, I'm taking 20 mm. You also can take 20 mm. But in few drawings, it will be written you're supposed to take 15 mm. In that case, instead of 20, what I'm taking, you have to take 15 mm. But right now, for my calculation, I'll take 20 mm. But also understand that sometimes the Chajja cover will be 15 mm, which will be mentioned in the drawing. Then in that case, you take 15 mm. Okay, is that understood? So 150 minus top cover, I'll take out 50. Sorry, 20. Bottom 20, I'll take it out. It will be 110 mm. Great. Okay. Now you may ask me one question, sir. This length, whatever you took, in the footing and all, you had taken 2/3 of this. If you remember in the footing, what I told, whatever depth you have, top cover you deduct, bottom cover you deduct, whatever answer you get, you take 2/3 of that. Good. But here the thickness is very small. The thickness is just 150. So in that case, you just take out the top cover, you take out the bottom cover. That is enough. You don't have to take 2/3 of this. Because if you do this 110 mm, this you can see this particular height, it is just 110 mm, and that is okay. If you take 2/3 of this will be even less than that. It will come out to be around 80 mm. So practically you cannot keep 80 mm something like this. You cannot bend it at all. I mean, it's very difficult to bend. So you don't have to take 2/3 in this Chajja case. Top cover and bottom cover you detect. Whatever answer you get, we got 110. So this distance will be 110. Okay. Now, second. Next, I'll calculate for 2 to 3. That is from here to here. This length I'll calculate now. Which one? Here to here. Okay. So how do you calculate? Again, it's very simple. Most of the things they have given it here. What all things is given? Yeah. So this is 800 mm. From the outer of the Chajja to this part, it is 800 mm. And the beam width, what you can see, this is 300 mm. That means this is 300 mm. So I'll add both the thing. Do you agree with me? 800 plus this 300 if I do, I'll get outer to outer distance, and one cover from this side and one cover from this. If I deduct, I'll get the straight portion of that. For the cover, I'll write it like this. So cover, one cover from this side and one cover from this side. If I do this overall length, if I add and deduct one cover from here, one cover from here, I'll get this particular straight length. Understood? So I've done the same thing. 800. So this is 800. This is 300 plus 300 minus 20 from here, minus 20 from here. So it is 1060 mm. Okay, great. After that, next is this portion, which is that this portion. This portion, you cannot see it here. It has gone behind the white color, but practically you can see this particular point to this portion. I want now this one, only this one, not this one, only this one. So this is equal to this. Okay, whatever length you got here, the same will be this only. So you can directly take 3 to 4. This is 3 to 4. 3 to 4 will be 150. This thickness is 150. Top cover you deduct, bottom cover you deduct, 110. 1 to 2, whatever you got, same will be a 3 to 4. So 110 and 110. This much is understood. Okay. So this distance and this distance will be same. You don't have to worry for that. Now comes the last and the important. That is, now I'll find this complete thing. That is, it will act like a beam stirrup. For the beam, we had done the BBS, right? So next I will find this one, this one, this one, and this one. This I want to find. So I'll name it as like this. 4. So this is 4, 5, 6, 7, and 8. So I written 4 to 5, 5 to 6, 6 to 7, 7 to 8. So I'll take it out separately. It is something like this. Okay. This is your beam stirrup, and I'll draw the beam also. So this is my beam. And what is the thickness of the beam? I mean, what is the width of the beam? The width of the beam is 300. Now you know the simple calculations that has to be done. And the depth is 500. Okay, that is mentioned. You know that, right? So depth is 500 and width is 300. Now, can you do the BBS for just only this particular shape? Easily you can do that. How you are going to do? 300 is a width. From here you take out the cover of 25 since it's a beam. This side also it is beam. So 300 minus 25 minus 25. And the depth is 500. Minus 25 from the top, minus 25 from the bottom. Whatever you get, that will be your cutting length for this particular stirrup. Got it? Same thing I've done it here. So 2 into means 2 times I've done. 2 into 500. This is 500 minus 25 minus 25 plus this is 300 minus 25 minus 25. Try to do this calculation. You will get 1400. That is, this is 450 and this is 250. 450 plus 250 is 700. 700 into 2 is 1400 mm. Simple. Very simple. Okay. Now I'll clear everything. Okay. If you have understood, I'll clear all these things. These things I'll clear. Not required. Okay. Yeah. So what few people do, like here, this is 500, isn't it? So in the 500, this top you'll take out 25 mm cover for the beam. Bottom it is coming under the Chajja. So for the Chajja, the cover is 20 mm. So what few people do is, instead of taking 25 in the top and 25 in the bottom, 25 beam cover they'll take. Bottom, since it's a Chajja portion, they'll take it as 20 mm. So you don't have to do all those things because 5 mm nothing will happen. 5 mm there won't be any change at all. Okay. So you don't have to do. You may see some other people doing that thing. If you want, you can follow that, but there won't be any changes. You can follow what I thought. Take out 25 from the top, take out 25 from the bottom. Okay. In the width part, there is no issue because this also comes under the beam part. This also comes under the beam part. So 25, 25 you can do. Only the depth part, this will be 25. And since this is coming in Chajja portion, you can take 20 here instead of 25. But again, like I mentioned, you can take 20. But like again I mentioned, it will not make any difference in 5 mm. So you can go with 25 each. Got it? Finish. So once you've done everything, we have got the complete cutting length. Last one portion which is left, that is a hook length. So this is my hook. Actually, this is wrong. This hook should be turned in this way. It will be turned in 135 degrees, something like this. Here the laborers find it very difficult. In order to finish their work early, what they do is they haven't bend it like this. Actually, this bar will bend like this. Okay, instead of keeping it straight, it should be something like this, like I've done it here. So what will be the hook length? Hook length we already know. Hook length, if you remember, at the time of stirrup, when we had a stirrup something like this kind of stirrup at the in the column lateral ties, I told you to take this as 13 times the D, 13D, right? Isn't it? If you had seen my column BBS, it was 13D I had taken. So I'll take 13D also. Few people take this as 12D also. You can take 12D also, doesn't matter. So, but here I'm taking 13D. So 13 into D is diameter of the bar. Here all the bar we are using a 10 diameter bar. So 13 into 10 is 130. So this hook length what I have, it is 130 mm. Got it? So in this way, if you do the calculation, you have got all the length of the bar. Complete whatever bar you can see, entire length we have found it. Now we just have to add everything. So you're going to find the total cutting length. This length I know, this length I know, then I know this length also, then this part, this part, this part, this, then this part, and also this hook also I found it now. So everything I have, you just have to add everything. So the total cutting length will be 110. So this is 110. This portion is 110. This straight portion is 1060. So add 1060 plus again this bend is 110, 110 plus 1400. So this 1400 is complete the stirrup part, this much part. 1400 plus 130 is a hook part. So here everything is done. But again, if you want to do the bend deduction, you can do that. If you don't want to do, you don't have to do the bend deduction. But usually since your formula, we are not taking it from center to center, you can do the bend deduction if you want, else you don't have to do. But anyhow, I'll teach you how the bend deduction should be done. Now count how many 90-degree bends are there. So now tell me how many 90-degree bends are there. One 90-degree bend is here. Agree with me. This is your second 90-degree bend. This is your third 90-degree bend. This is your, okay, anyhow, I'll strike out everything. Yeah. This is one 90-degree bend. This is second 90-degree bend. This is third 90-degree bend. This is fourth 90-degree bend. Then again tell me. Yeah. Fourth. This is fifth 90-degree bend. And then one more here. This is sixth 90-degree bend. Agree with me? So altogether there are 6. 1, 2, 3, 4, 5, and 6. So 6 90-degree bend is there. One 90-degree bend we know is how much? 2D deduction. So 6 into, so there are 6. So 6 into 2D I'm supposed to do. And D is the diameter of the bar. So 6 into 2 into D is 10. So 6 into 2 into 10 is what I've done. Okay, fine. Last one portion is left out. This particular bar will be bent at 135 degree. You cannot see it, but it is 135. So this angle will be 135 degree. So 135 degree bend, we take 3D deduction. We take 3D deduction. So only 135 degree bend is there. This is only 135 degree, only one. So we have taken 1 into 3 into D is again 10 diameter bar. So 1 into 3 into 10, you have to deduct. So this much part, whatever you can see, it is a bend deduction part. So now try to do the complete calculation. 110 plus 1060 plus 110 plus 1400 plus 130 minus this comes out to be 120 minus 30. If you do, you'll get total cutting length is 2660. So if you ask a bar bender, or if you ask me, tell me what is a cutting length if I want to prepare a bar something like this. So I'll tell, bring a bar which is 2660 mm or 2.660 meter, and then I'll tell you how much should be this. This is 110. You keep this portion as 1060, and again you keep this as 110, and then you keep this as how much it is, 300 minus 25 minus 20 is 250. This you keep 450. This you keep 250, right? This you keep 450, and this hook length you keep how much? 130 degrees. So in this way, if you prepare, you require 12260 meter of 2660 or 2.66 meter of a bar is required. Simple. So in this way, we have done the BBS for the gun bar. Now the next question is, how do you put it practically? So practically, you might not have seen this. So I'll show you practically how it is put. Okay. First is to find the number of gun bar. So this gun bar, where you are going to provide, wherever you have this window opening, there we are going to provide a gun bar. Like this is a window opening. Of course, this is a cut lintel. This is a full lintel. If it is a full lintel, you have to take the complete length. If it is a cut lintel, only in this portion your chajja will come. Okay. If you don't, if you haven't seen that, then I'll show you one image for that. Yeah. Yeah. So in my site engineer course, I've explained you all these things, but anyhow, I'll show it here. Okay. This is that bar, how it looks. Okay. Sometimes people, what they do, they bring a bar like this, they bring it here, and from here they have to bring it like this, but here they'll take it like this. So some people do like this, or some people do like this also. I mean, they'll bring a bar, then it will be given like this. Okay. Then it will be given like this. But in this case, what these people have done, they brought it like this, then a stirrup has been done. Okay. And then finally they have brought one more bar like this. Okay. Anything is okay for us, not an issue. Yeah. Now how many such number of bar is required? For that, you should know what is the width of this opening. You should be knowing what is the width of this opening. Okay. I mean, this length of the opening should be known to you. Only then if I divide this by the spacing, I'll get the number of gun bar. Got it? No? This much understanding you have? So this is that gun bar they have put 1, 2, 3. For that, you should know what is the length of this opening. Okay. So here I'll do certain assumptions. Like I'm assuming that my window opening is 2500. I'm assuming that my window opening, what I have from here to here, it is 2500, and the spacing is by default given here. You have to provide a 10 diameter bar at 150 center to center spacing. So this opening is 2500. If I divide it by 150 and add +1 to that, because it is numbers, so you'll get 18 number of gun bar is required. This much is understood. So how do you find the number of bar? You have this opening. In this opening only you are going to provide the chajja, and here it's, and in this area, in this length only your gun bar will come, which will come in the perpendicular direction. In this way your gun bar is going to come. Okay, this direction. I hope, like here, in this way. 4, 5, 6. So in this way, so whatever is the length I have, that is 2500. I'll divide it by the spacing +1. That will give me number of gun bar. Next is distribution bar. What is a distribution bar? If you observe it carefully, this was your main bar, right? That is a gun bar. Beneath that, you are going to pass a bar, which is called as a distribution steel. So how we will find the cutting length of the distribution steel? So you can see the distribution steel here also. See, this is also distribution steel. To find the cutting length of a distribution steel, you should know what is the length of this. And if you know the length of this, you can find the distribution steel cutting length. Okay. So for that, again, I'll go back here. So the cutting length of the distribution steel will be how much you're going to do. I'll take it out. This is not required, I feel. It will make confusion again. Yeah. Okay, fine. So what you will do, you know the length, the cutting length, the cutting length of the distribution steel will be, this is 2500, this is 2500. From this side I'll deduct one cover, from this side I'll deduct one cover. So 2500 minus 20 will give me 2460 mm. This is a cutting length of your distribution steel. So 246. So this is the cutting length of my distribution steel. From here to here, the length is 2500. I'll take out one cover from this side, one cover from here, one cover from here. So whatever length is left out, so this is the length of my distribution steel. Same thing here also. Understood? This much you have understood? Fine. And the last portion what we have is the number of distribution bar. We found the number of gun bar. We found the cutting length of the distribution steel. But how many distribution steel you are supposed to provide? So one thing you have to understand, your distribution steel will be put only in this length. This is the length. only up to this region your distribution steel will come. You can see the black color. These are your distribution steel. What is the length given? What is the length? It is 800. So in 800, you have to deduct one cover. This cover you are supposed to deduct because your bar is not starting from here. You are leaving a cover and your bar is starting from here. 1, 2, 3, right? And why? And should you deduct any cover from this side? No, because it's a continuous portion. So no cover has to be left from this portion. 800 minus one cover. So cover is 20 mm. So 800 minus 20 is 780. So 780 divided by spacing. Spacing is 150. Okay. So I've done the same thing here. 800 minus 20 is 780. 780 divided by 150, the spacing plus 1. So 6 number of bar is required. So practically, if you ask me, we are going to provide 6 number of distribution steel. 1, 2, 3, 4, 5, and 6. Okay. And what was the length I took? Length I took 800 mm. So this 800 mm was from here to here. This is 800 mm from this is 800 mm from here to here. Out of this 800 mm, the first bar what I put, I'm going to leave a gap of 20 mm. I'm going to leave a gap of 20 mm. So this is a 20 mm gap what I have left. And this is 800 mm according to the drawing. Okay. 800. So 800 minus 20, this gap in the sense cover. 720 divided by the spacing I have done. So why haven't deducted the cover from here also? Because this is a continuous. You have a beam reinforcement coming. This bar will end here only. So you don't have to take a cover from here also. In the normal case and all, what we used to do, we used to do the deduction from both the side because it was exposed in both the side. Here, this particular bar, if I don't leave a cover, it will be exposed outside. Whereas the last bar what I have, if I don't detect the cover also, no problem because the beam reinforcement is coming. But if the same bar was somewhere ending here, if the same bar, just in case if there was no beam, if it was ending here, then you should have deducted one cover from here because this side it is exposed to the atmosphere. But here it is not exposed to the atmosphere, it is already inside. So that is the reason I have deducted only one cover from the outside, this outside portion. Here it is not required. This much you understood. So in this way you got how much number of bar? 6 number of bar. You got finish. So in this way you can do the Chajja calculations, and remaining Excel sheets you do it on your own. I think most of the Excel sheets you have done. One thing you have to remember, don't do all these things in the Excel sheets. Like you don't have to put the shapes and all. You just write Chajja, you just write what is the cutting length, number of bar and all, like we have done it here. No, you don't have to do the shape of bar. If you want, you can do it, but it doesn't make a sense to prepare a bar something like that. You just write a bar description, gun bar, the number of member is 1, dia is 10, spacing is 150, number of bar you know how to do, and directly write the cutting length here. Based on that, you can prepare it. Try to do it. If it doesn't happen, you can always get back to me. Okay. Other than that, most of the things I've explained you how it has to be done. Yeah, Chajja portion is understood. This is also I've explained you how it has to be. Practically also I've shown you how it has to be done. Okay. That's how the entire BBS has to be done. I feel there is nothing left in this to explain. Try to do these calculations. Try to do it manually, and then you can go ahead with the Excel sheet calculations. Okay. Yeah. Okay. Fine. So we'll see you back in the next lecture. Thank you.